video we will first review variable length arrays and then learn some new things about them. Okay, so it's a local array that is allocated without knowing the number of elements, and this must be strictly greater than 0, otherwise it's undefined behavior. But if it's too big, then the program will crash. What happens is that the stack pointer will just be adjusted, and it can be really disastrous. So if the stack is like this, and we come here, and then we have the heap, say the heap is here, and we request a really huge amount of memory, then it will go into this, and well, it will not be pretty to see. So it's really dangerous to use variable length arrays if we don't know the input. So it should be checked first. For instance, we can use two versions of a function or implementation. One which uses VLA, since that is faster, and the other which uses malloc or calloc. Okay, recall we cannot and should not return deallocate this memory. It's done when we return from the function. Okay, and it would be a really bad idea to write something like this: return A, since the memory will disappear as soon as we reach that point or that point. So that should not be done. Okay, we can only use variable length array for a local array on the stack, not for global variables and not in structs. And that means it should be a so-called ordinary identifier. Okay, well, after C11 it's only optional, but GCC and Clang are available in most places. Clang is also well, all operating systems now have GCC and Clang, so there is no reason for not using VLA. Clang is supported natively on Windows, and that was done by Google when they wanted to compile the Chrome, well, not only Chrome, but their software on Windows with Clang, so they could use the same compiler on all platforms. So they made a port to Windows of Clang. Okay, and that is it. Well, okay, never mind. What I was going to say is that the release manager of Clang is a student, well, not a student any longer. He works for Google in Munich, but he is from LTH, Hans Wenboy. Okay. Okay, so there is an alternative to VLA, and that's called alloc A, and that does essentially the same thing, namely allocate memory from the stack, and then return it when the function returns. Okay, so now the question comes, is a variable length array, is it compatible in the memory layout with normal arrays? So if we have a function that has no idea about getting input from a variable length array, can we pass a variable length array to this one? Yes, we can, if the sizes match. Otherwise we cannot. And there is no reason or hope to expect that the compiler will, or the runtime system will check this. It will just crash in a horrible way if it doesn't work. well, it doesn't have to crash, of course. It can compute the wrong result or the correct result, but no runtime or compile time checks are required. Okay, so if we have this case instead, that we have a parameter which is a variable length array, is this dangerous? No, it's not, because this just takes the parameter as, the array as a parameter. So the memory for this matrix must have already been allocated. For instance, like this. It's important to declare the parameters that are used in the VLA before the VLA. If they would be, if this one would be put before, and there would be a global variable such as int n here, then the compiler would see this, and then it would see this, meaning this, and then it thinks that n is that n, and not this one, which it should be. So put the declarations in this order to avoid troubles. Okay. If we want to have this function and use a header file with this, then we can write it like this. But it's also permitted to skip the variable names in prototypes. This may be a bad idea, since it's nice to have variable names instead of a long list of ints, for instance, without names. But it's permitted. For instance, malloc is usually declared like this. And we can remove the variable names here as well. And then to do that, the syntax becomes like this. Okay, now the question is, or actually another question is, can we remove one of the array brackets from this matrix parameter? Recall that an array, when it is a parameter, is converted into a pointer. Okay, so that means the first one is converted into a pointer, and that means we can also write it like this. Okay, we can start writing it like this, since we convert it to a pointer, and since we have converted it to a pointer, we can also write it like that, because the first dimension is unnecessary. Okay, but this, these two are not the best looking code you have seen, I guess. Okay, another thing which is not a variable length array, but very much related to it. It is to have a pointer to a variable length array. Okay, so what this is this P is has type variably modified type, and that means there is a VLA in the type, but it's not the complete type. Okay, and what can we do with this? Well, we can, what it says is that we allocate P points to an unknown number of such arrays. Okay, so we have an array from 0 to n minus 1, and that's what P points to. And since it's a pointer, there is an unknown number of such. And that means we can write like this. Well, for instance, if we allocate everything in one step.